2014.
Woo!
Everybody, this is our annual event. It is now a tradition. We have even a remote here, Dr. Carroll, so let's see if this works. So this is 5 slides prepared ahead of time. We get here, and the person who wrote the slides did not present them. They get swapped. Presenter has never seen the slides before, except Michelle, because we had she got a peek ahead of time. Once edification ensues. All right. So you will have 7 minutes each. At 6 minutes, the LEDs will change color. At 7 minutes, come on, you can do it. They start flashing. At 8 minutes, I unplug the projector and remove you bodily from the room. All right, so that's our timing mechanism. Students, go to this. It will redirect you to where the survey is. So that's GOO.GL56A, lowercase z, A.
You're voting on it.
A.
Let's write this down.
Everyone
I got it memorized.
able to get there? Okay. For each speaker and each set of slides, it's one big page. You'll be scrolling down as you go. There's separate rating for the speaker and for the slides.
Tabitha, is that a capital 5 or a...
No, it's clearly a lowercase 5. Come on. All right. All right, and then you submit it once. So say you're submitting until the end. Okay, hopefully, so we're doing this way, so hopefully the results can be tallied and I can present the trophy by the end of the seminar. Okay, the order was determined by random, except that Michelle is going first. We used random.org that uses randomness from atmospheric noise. So it's truly random. Okay. The order is this. Dr. Arnold will be presenting slides created by Dr. Carroll. Woo! Dr. Zollinger will be presenting slides created by Dr. Arnold. Dr. Inglefield will present Dr. Zollinger's slides. Dr. Armstrong, Dr. Inglefield. Dr. Carroll, Dr. Armstrong. I'm excited. All right. Remember, go there. Has everyone been able to load this up?
Stay sensitive.
Yeah.
Awesome. This, Dr. Arnold, come on up. Next slide. All right, so let me get out my timer.
I'm already done. What color do you want these when I start?
So they will be red. They'll change color when you're at 6 minutes.
Okay, so I can start?
And now you can start.
Okay. So I'm very happy to be here to talk to you guys today. And I would like to talk to you. So in designing this presentation for an upper level physics crew and other science people and other people from here at the university, I asked my 5- and 6-year-old, what should I talk about? They suggested that I talk about pumpkins, since all this week they've been dealing with pumpkins, and on Friday we're going to crack our pumpkin open and actually find out what's inside of it. It's jack-o'-lantern. And so I decided I would talk to you about the interior structure of a pumpkin, but we'll do it, instead of from a 5- and 6-year-old perspective, slightly above. But we'll talk about it using some basic physics. And so most of you know that one of the earliest experiments done to investigate the interior of something was Rutherford's scattering experiment, where he was trying to figure out what was inside of what was believed to be a solid object, an atom, and so it would make sense to do something like that, probably, to figure out what's going on with our pumpkin. Now, pumpkins are much larger than atoms. We can see them. Atoms we can't see. So it would make sense that instead of firing something else that you couldn't see, it would make sense to fire something you could see. This is Rutherford's experiment, like, gone big. And I'm sure that Rutherford actually would have found the experiment much easier if he could have done it as opposed to having to use invisible alpha particles and tiny little atoms that he couldn't see. If he could do this, think of how quickly we would have learned about atoms as opposed to having to wait decades to figure this stuff out. Now, if this experiment is carried out with a pumpkin, so if we go back, I forgot to mention something really important. That's bad when you do that, right? So what was really important about Rutherford's scattering experiment is that some of the invisible alpha particles came back, and he knew that because he saw them. Well, and so we'll see what happens with our pumpkin. Do some of them come back, and is there this dense nucleus like there is in the atom? And obviously, go try this at home. I highly encourage you to do that. If you try this at home, you will see that if you fire something at a pumpkin, it typically goes through the pumpkin and does not come back, unless, of course, you use a tennis ball, and then it gets all confusing. So obviously, pumpkins have no nuclear structure. There must not be a dense center. Okay, so let's use some other physics. So number 2, what else could we do? X-ray diffraction. If you'd like to know more about this, I suggest you talk to Dr. Inglefield, because this is more his specialty. But the gist of it is you fire a bunch of X-rays at stuff and see what they do, and you get these pretty patterns like this, and you can see the X-rays too. It's really cool. And so you get pretty patterns, and you can figure things out about how the atoms are put together based on these pretty patterns. So let's see what happens. So obviously, this is an X-ray of a pumpkin. And the obvious thing to compare it to would be DNA. It's very complicated why you do that comparison, and I don't really have time to go into that. But DNA probably should be compared. And DNA and pumpkins obviously don't look at all alike. When you do X-rays and X-ray diffraction and other X-ray stuff with them, you get those two pictures. So we can make another important conclusion that pumpkins are not of this earth. I told you a 5 and 6 joke helped me make this. Okay, so let's carry on. Other physics that we can do to learn stuff about things. Linear accelerators. These are big, huge tubes that we send things through and get them moving super fast. So obviously, if you took something and got it moving super fast, you should be able to figure out something about it. And you probably do a graph of something. And you probably get little peaks, because usually chemists do this, and then you can label the peaks with what the stuff is based on how it accelerates and how fast it goes. And I'll just let you look at that for a moment. So everybody's with me?
Yeah.
Okay. Obviously, linear accelerators are small tubes made for things like protons and alpha particles and things that are really tiny. Our pumpkin is not really tiny, and you can't really shove it into one of those tubes and get it moving super fast.
No sign of discreet.
But the physics majors are really good at getting pumpkins to go super fast. And all you have to do is drop them. And then gravity is an awesome accelerator. We should just do this with alpha particles. Drop them. And that means it's so much cheaper to make these big tubes. And then gravity will just naturally accelerate anything with mass. And so the pumpkins will accelerate and give that mess. And if you look, there's no peaks, right?
Color change.
There's no cool peaks. So obviously pumpkins don't have any atoms in them because we don't get those cool atom peaks that you all think you understood. So my colors changed. So unfortunately, I don't have a lot of time to explain the giant hadron collider, and that's good because it's super complicated. But basically, you collide things, you smash them together, and see what happens. And once again, so we can throw things at things, we can get them to move really fast, we can smash them together, which is what we're doing here. We have lots of ways of figuring out what things are made out of. So this experiment was carried out by Dr. Carroll's research group. And unfortunately, an injury occurred and no final data has been collected. But I've heard that they plan to reschedule it for this weekend after Halloween, and they'll try this again and hopefully get better data. So quick conclusion, pumpkins do not have any nucleus. They are not of this earth. They do not contain any atoms. And my husband, when I first went into physics and explained to him dark matter and dark energy, he said, whenever you physicists don't understand something, do you just call it dark? And I said, well, yeah. Since we clearly have no idea what's going on in the interior of a pumpkin, it must be comprised of dark matter, and hence we like them. And I don't see that much either. Tabitha, you can field questions. People can speak up. Brett.
So, Dr. Arnold, if you had to summarize your slides that you made, could you do that?
You mean the ones that you're about to
No,
present?
no, I just,
Oh, my children made those.